We're here doing AP review again. This is 2005 Form B, AB, BC, free response number 5. Consider the curve given by y squared equals 2 plus xy. So part A asks you to show that dy dx equals y over a 2y minus x. So whenever they say show something, they're telling you, yo, this is totally true, just do the math to back it up. So if I want to find the derivative of this thing, I need to do it implicitly because it's not easy, nor is it worth solving for y. So when I derive y squared, I'm going to get 2y dy dx, right, because I derived some y stuff, equals, I derive the 2 and it's gone, which is great, but when I derive xy, it's a product rule. So u dv, which will be dy dx, right, so u is my x, dv is dy dx, plus v, which is y, du, which is just a dx or a 1. So now what I want to do is move all my dy dx's to one side, so I'm going to subtract my x dy dx over, so I get 2y dy dx minus x dy dx equals y, and then I'm going to factor out a dy dx, so dy dx times the quantity 2y minus x equals a y, and then I'm going to divide that over, and I'm going to get dy dx equals a y over the quantity 2y minus x, and that's what they asked me to show, right? I want to make sure that I write it exactly the way they told me to write it, and the way they wrote it was y over 2y minus x. So make sure that you show that by writing your answer exactly as theirs is. So for instance, if you had ended up with a negative y on the top and a negative 2y plus an x, it wouldn't be mathematically wrong, but you need to go the extra step to show that your answer is identical to the answer they requested. Cool. Awesome. Part B. Find all points x comma y on the curve where the line tangent to the curve has a slope of 1/2. Great. So let's say you had done part A wrong. Like, let's just say, oops, totally biffed part A. Make sure that you use the slope they gave you in part A to do part B, because in this rare instance where they give you the right answer, you want to recognize that you're trying to set dy dx equal to 1/2, right? And in this case, they told you that dy dx is a y on top of a 2y minus x, and that's supposed to equal 1/2. So I'm going to cross multiply and then clean some stuff up. I get 2y equals a 2y minus x, right? Because I cross multiply like this, right? So when I clean this up, I'm pretty sure I get x equals 0, because when I move all the y's to one side, it's going to turn out it doesn't matter what the y's are as long as x is 0. So once I know that x is 0, they asked me for the points x comma y. So I go back up to my original function, and I plug in x is 0. So if I want 0 comma blank, I say, cool, that's y squared equals 2 plus a 0 times y. Y squared is 2. Y must be plus or minus the square root of 2. So my answer are the 2 points, 0 comma root 2 and 0 comma negative root 2. Right? Remember, they wanted the points x comma y. Cool. Part C. Show that there are no points x comma y on the curve where the line tangent to the curve is horizontal. Cool. So they're specifically telling you this is not going to work, right? So that's important information. They're saying in part C, show that that dy dx equals 0, which means a horizontal tangent line, won't happen, right? Show that that's not possible. So essentially what we're saying here is if we set dy dx equal to 0, that would be y over 2y minus x equals 0. If I multiply the denominator over, that means y is 0, right? Well, the trick is that if you try to plug y equals 0 into your original curve, right, on the curve, there are no points where y equals 0, because that would be 0 squared equals 2 plus 0, 0 equals 2, that's a lie, right? So there are no points on the curve such that y equals 0, right? So essentially what I needed to show was that in order for dy dx to be 0, y had to be 0, and that when I plug 0 in, that's a lie and it can't happen. Cool, so 0 does not equal 2, and that's why there's no such point. Cool. Part D. Let x and y be functions of time t that are related by the equation y squared equals 2 plus x times y. At time t equals 5, the value of y is 3, and dy dt is 6. Find the value of dx dt at time t equals 5. Cool. This is sort of a related rates question. I mean, it's a related rates question that's hiding as a parametric question, but it's not really parametric, which is why it's allowed to be on an AB question. So if you derive this guy with respect to t, so now we're going to derive with respect to t. So the derivative of this guy with respect to t is 2y dy dt, because I just derived some stuff that wasn't a t, equals, I derived the 2 and it's still 0, great. But this is still a product rule. What's different now is I'm not deriving with respect to x, I'm deriving with respect to t. So u is going to be x, dv is going to be dy dt, not dy dx, plus v, which is y. And now when I derive x, I'm not deriving x with respect to x, but with respect to t, so I need a dx dt. Great. So now this is our new equation, right? 2y dy dt equals x dy dt plus y dx dt. Great. So now let's list the stuff that we know, right? So we had an equation, we derived our equation with respect to time, and that's what we got here, right? Because when you do related rates, remember that you're using dreads, right? You need a diagram and rates, but here there aren't really any diagrams. You need an equation that you derive, right? And then you're going to substitute stuff. So let's make a list of what we know. We know, right, specifically, we know that we're talking about when t is 5. So we're talking about at t equals 5. We know that y equals 3, right? So, and if you want, you can be super specific and say that y of 5 equals 3, right? We know that dy dt evaluated at t is 5 is a 6, right? And we want dx dt, right? We want dx dt evaluated at t equals 5. Great, that's the question mark. Problem is that there's one glaring omission here. We know y, we know dy dt. We know dx dt, we know y. We want dx, I'm sorry, we know dy dt, we know y. We want dx dt. This is the thing we don't know, right? So this is the thing that we want. We know this, we know this, we know this, we know this. We need to find x. In order to find x, and that's the trick to this problem, we're going to go back to the original equation, right? So we know the relationship between y, which is 3 at this point, and x. So 3 squared, which is 9, equals 2 plus x times 3. So 7 equals 3x. X must be a 7/3, right? So now I know x, and I know everything I need to find my dx dt, right? So this is the thing I want to solve for now. It's up to you if you want to plug in the numbers first. There's definitely an advantage to doing that. So what I'm going to suggest is that you go ahead and plug in 2 times 3, because that's your y, times 6 equals x, which we now know is 7/3, times 6 plus my y, which is 3 times the thing I want. The advantage doing it this way is that you get rid of the stupid 7/3. If you try and solve first, it can be a little bit messy. So I'm going to suggest that it's easier to go ahead and do this first. So what I'm going to get is that this is a 36, right? Equals a 42 divided by 3. Why is my brain broken? Sorry, it's a 14, right? Because I'd cancel the 3 with the 6, plus 3 dx dt, right? I subtract this guy over and get a 22 equals 3 dx dt. So I'm going to get 22/3 for my dx dt. Now, if you actually look at the AP scoring guidelines, they didn't do that first. They actually solved for this first before plugging in the numbers, and in my opinion, it was a heck of a lot uglier. Again, it's entirely up to you and your preference for how you do things, but I think it was significantly easier to plug in the numbers, clean them up first, and then solve.